Hi, it's Mike Stevenson here. I've had a few questions the last couple of weeks off people about how do I get started building an enterprise integration platform with Azure Integration Services, and I made some notes on my blog the other day of things people should look at, but I thought it might be a good idea just to sort of brain dump a few ideas on a whiteboard that I think people might find interesting. Um, so this is my kind of just off the cuff attempt to see if I can put something together. So we're trying to build an enterprise integration platform. If you've seen some of the talks I've done in the past, you would often see it would look something a bit like this. So we've got this set of Azure integration technologies. We group them into sort of areas based on capabilities. So things like if you're building an API solution. Sorry, let me fix my whiteboard. I have a habit of doing that. So if you're building an enterprise integration platform and you need API capabilities, you might use a logic app and API management. You might the beauty of Azure is there's a whole bunch of other stuff you could probably do as well. You might do functions in here. You might build a web API component. You've got all these technologies to choose from, but this is really a capability type diagram. So really what we want to talk about today is how do you go from this to something, let's say make it real. So we want to get started. What kind of things do we need to start thinking about? So first off, I would say your integration platform, it's not just about technology. And I think that's a big mistake I've seen companies make in the past where you'll start investing in a technology and you kind of get so far, you hit some problems, and then the technology gets the blame, and you change the technology thinking that solves your problem, and actually the technology is the bit that doesn't really often won't change that much. It's really if you can't use the tools, you're never going to be successful with the technology. So I think to begin with, let's talk about the people. If we think about whatever you do, whether it's security, other parts of IT, or whatever, this idea of people, process, technology. You need to look at those three areas in how you're going to do stuff to be successful. So let's chat about the people first. So if we think about your integration team, what are the people that you're likely to build? So, or you're likely to need? So you're going to have something like an architect. So the architect is going to be responsible for how you do stuff, for what your landscape's going to look like, what technology choices you're going to make. And so you're going to have an integration architect in here, but that person's going to need to collaborate with your enterprise architect because you need your integration strategy to be aligned with your overall enterprise IT strategy. So there's going to be a relationship there, but there's also going to be other architects like security, infrastructure, various application architects. They're all going to be stakeholders that the integration architect is going to collaborate with, but that person's then going to come up with a bit of a plan and a strategy of how, what, managing the why, and they come up with the idea of what are you going to build and how are you going to build it. Now you're then going to have some kind of development team. So this is one of the things I think a lot of companies need to think about is if you start off with integration, you may have an existing team. It may be a new thing that you've done on an ad hoc basis before, but you're trying to do it more strategically. So just having a developer coming in, doing some stuff, go away, then you get another developer 6 months later do something else. That's going to be a really fragmented approach. And you're going to have challenges with that. Now, that might be great for some small organizations, but I would expect bigger ones would be thinking about the idea of sustainability. So how can I build solutions that I can live with, that I can change in the future, and that I can manage? I think it's an important part of it. This is where your team comes in. So you're likely to have something like a dev manager, and then a bunch of devs. And ideally, if you have good processes in place and you have some good people in key roles, and then you're effectively using the technology, if you need to scale your integrations up and down, because one minute you've got 10 projects, then you've got 2 projects, then you've got 20 projects, ideally you should be in a place where um, you can scale your dev team, so you can add new developers. They would ideally come in a way and work in a way that's consistent. So one of the things I encourage all of the customers that I work with is these developers should be able to swap between projects, and the solution that the developers build should be built in the same way. So if you imagine you're building a housing estate with lots of houses, you would tend not to build the houses all completely individual. You would tend to have 2 or 3 standard types of house. And that means if I know how to build like a 2-floor, 4-bedroom house, I can build any 4-bedroom house. It could be used by different people, but the house is the same. And I think having that kind of idea in your dev team makes the team scalable, so you can add and remove developers and scale up and down. You're then going to have testers, so you need some people who know how to test the solutions. Same principles apply here. If you're able to scale your testing capability up and down, that's going to be a good thing. You're also going to liaise with other teams, so whether it be your devs or your architect, you're going to have stakeholders for the business, you're going to have application stakeholders, and you're going to have business partners. So sometimes, if you've got like say 5 people working on integrations with one application, but you've only got one application expert over here who knows about that app, you're going to have some bottlenecks. So you need to understand, what are your key applications? Have you got the right people to help you integrate with those applications? And that again can be a key to success. It's not just about your integration team, it's about the collaboration with other people in parts of the business. I think again as well, this sort of relationship to business stakeholders is really interesting. So I think often we can think of the relationship as being very much this way. We get requirements from business stakeholders, we liaise with application teams, and we deliver the requirements. But I think there's also a big PR exercise that integration teams need to do to be successful. So I would expect that the integration architect and the dev manager should be communicating back to business users. So they would communicate success and manage their things like risks, issues, and requirements. We need to have a good relationship with our business stakeholders, and kind of creating an understanding of what you've got an integration platform. What is it? Why is it important? Why it makes their life easier because they have more successful projects, and helping the business users understand what it is. Because for a lot of people, an integration platform is something you don't see. So whenever there's a problem, you just hear that there's an integration problem. And PR can be really key to being successful. So when you have people managing these stakeholder relationships viewed as two-way, I think then we've also got, from a people perspective, it's not just about structure, but it's investing in skills. So a lot of companies doing AIS solutions, there's going to be a skill investment to teach people the skills that you're going to need. If we think back to here, there's a lot of different skill sets involved in here. So which ones are you going to use? Which skills are worth investing in? And also, things change over time, so you need to view skills as like a continuous learning thing. So having people, particularly in your dev area, if you've got people who like learning and love learning about new technologies, that's going to really help your team, and you should encourage that. Okay, so next up, tactical integration versus strategic integration. So there's 2 types really. So if you're going to be a company where you're going to come in, you're going to build an integration from A to B, and it's going to be a one-off, and you're not going to do integration for 6 months. You're not really at a point where you're thinking about tactical integration, and you may do these very ad hoc integrations occasionally. This is where I think don't overcomplicate it. If you're thinking about strategic integration platforms, but you deliver tactical integration solutions, you don't have many of them, you're just going to make your life difficult. So, this is where things like on the Azure Integration Services platform, things like Logic Apps, Power Automate can help you build these tactical integrations in a way that will be successful, it'll be low cost. And I think just leave it at that if that's what works best for your organization. But I think when we start thinking about strategic integration, we're then going to the bigger picture of, we're going to be looking at something like we've got system A, system B, system C, D, E, F, and things like the old bus patterns might still be relevant. You might do ad hoc integrations here. You might have APIs exposed. You've got lots of integrations going on with different systems. You're constantly changing. You need to drive business agility. You might have things like digital transformation programs going on. That's where having a strategic view to how you do integration, that'll help you be successful. So things like in a previous YouTube video, I did a video about extensibility points on an integration platform. That's the kind of thing where, if we think about the maturity, so if we take a standard maturity model, so over time, your chances are you'll start off here, but then you want to get more mature. And every time you're doing projects, improving your maturity means when you do a project over here, you're constantly having new projects in the organization. So when you've got a highly mature integration platform, you should find it easy, cheap, low risk, and effective to do new projects because you're leveraging the assets that you've built previously to help you deliver good projects. Okay, so I think one of the first things probably you want to think about is environment. So leaving this till late just creates problems. There's a lot of things about integration platforms being successful that come back to environment management. So the questions you need to think about here are, what environments do you need? What systems do you integrate with? And then off the back of that, what environments do they have? So one of the customers I've worked with, we had, so I'll just draw these as boxes. So we would have a dev environment, and they would be for developers to go and write code and connect where they needed to the systems to be able to help them write code. We then would deploy from there to a build environment, so we'd have an automated process that would basically develop our integrations, test them against various systems, and then we would be able to create a package that we could deploy to other environments. So off the back of the build environment, we'd have a system test, we'd have a UAT environment, and then you might deploy to these, but the key thing was from the UAT environment you would then consider going to production. So there's a couple of things to think about here. Number one, you've got various companies who all do these different ways. So some companies might have, I think the most I've ever worked with was a company who had 4 UAT environments. You might have 3 of these, but you might just have one, and you might have one of them. That's quite realistic. You even have some companies who may not have a UAT. They may not have a build environment. They may not have system test. They may not have build. I think one of the things you need to decide first off is what environments make sense for your organization. So if you've got more environments than you have developers, you're probably making your life difficult. But if the more environments you have, the more it becomes a discipline and probably somebody's job eventually just to manage those environments and just to manage deployments to them. So there's trade-offs, and it's really a spectrum about where do you want to be. Now, if we think about these environments, so let's say what systems have you got? So some of the challenges you might have. So we had things like SAP. We had, let's say we've got CRM on Dynamics. We might have Maximo as an IBM system. Now, in dev, you might point the dev environment to each of the dev environments for these systems, and that makes it really easy for your developers. But not all of these systems might have the same environment. So if you've got, when your environment plan comes together, let's say we've got dev, build, UAT, system test, prod. If every application has these same environments, that makes life quite easy. But sometimes an application won't have that. So for example, let's say SAP, it's probably quite expensive to have an SAP environment. So maybe SAP has dev, UAT, and prod. And then we have CRM, which might have dev, system test, UAT, and prod. And then IBM might only have test and prod. So the question is, what do you do for each of these environments? So for development, you need to point to, let's say we point to dev, and test. But then your automated build environment. So what we did is we just pointed to the same environments the dev environment did. We're treating them as being, volatile, capable of dealing with lots of change going on. And we just did that. So we pointed to every other system's dev environment. But on system test and UAT, it gets a bit more complicated, because in dev and build, you're probably running automated tests. And ad hoc developer tests. And probably, if you think about a typical integration, so let's say we've got an integration that goes SAP to AIS for integration, to CRM, and then something else comes out of CRM to integration, and then goes to Maximo. So this might be a business process that happens here, and then it goes down here. There's two parts to it. So you might be likely to test end to end in something like your UAT environment, but in your dev and your system, well, certainly your dev and your build, you might only test certain bits of this process. So there's different nuances about how you're going to use these, and certainly in things like the dev and the build environment, if you can do any mocking here, or you can do any stubbing, that's going to make your life easier to drive your automated tests. But then you do take on the risk that you need to still fully integrate in your system test environment. Now, in this scenario here, what we did, and the example up at the top, is we would point our system test to application dev environments, UAT we'd point to test, and then prod we'd point to everybody's prod environment. And what we would do is we tend to focus more of our end-to-end and testing in the UAT environment. And here we'd be focusing on stability, and then we'd be focusing on does the requirement get met? Whereas in system test, we'd be focusing on more, does it work? We may deploy regularly, so you might deploy like every day to system test, but then you might deploy every other week to UAT or something like that. It depends a lot on the project you're doing, and some projects might deploy daily to UAT, and that again, it's the variance nuances of how different projects and different customers want to manage these environments. You've then got all the challenges of, right, so if we've got one project going on, what about multiple projects? So if we've got one project using 2 of the systems and we've got 10 systems we integrate with, and that's the only project we're doing, things aren't really too complex. But if we start having 3 and 4 projects going on at the same time, and 2 projects are changing SAP, 3 projects are changing Maximo, and 1's changing CRM, but they're all doing different things with different integrations, then it starts getting a bit chaotic, and we have to start managing that. So the first thing is, does that then become somebody's job to coordinate how the projects use the environments? Sometimes you'll have requests for other ad hoc environments. So you might have a new project that says, we want a new environment, but then suddenly there's a question of, right, well, if we've got 100 integrations, which ones need to be deployed to the new environment? And, so one of the things on Azure is, being able to delete resources is a good thing. So we can bring up a temporary environment to support a project, get rid of it when you're done. So that delete resources can really help there. But there's lots of things to think about how you're going to manage your environments. And I think the key thing here is going back to understand who your stakeholders are, understand what their requirements are going to be, and then maybe come up with an environment plan before you make all of your architecture decisions, because that volatility in your environment plan may affect how you decide to build your platform. I guess the one thing I would say, try to avoid, so that this is where one thing that always gets really complicated is, if let's say we have AIS, sorry, let me just sort that out a bit. So if we have AIS system test here, and we have AIS UAT, and then we've got SAP dev and SAP test, and we've got CRM and CRM test. Now, one of the things that sometimes happens when you have project conflicts is, normally you'd have something like this, but then you'll have a project comes along and says, for this project we need to point UAT to the dev environment, like that, and then we need to flip it back, and what it's not that it's not doable, it just kind of creates a lot of questions about, well, it's easy on this diagram, but if I've got 10 different interfaces that go to CRM dev, some of them are for SAP, but some of them are for other projects, what do I do with the other 9 interfaces? Do I repoint them all? Just repoint one of them? And what happens if things like, if you think about, that might be one integration, which could be, let's say it's this bit here, but we know the end-to-end business process covers this other section. So if CRM dev starts pointing data back out to other interfaces that came from SAP test instead of dev, does that change here cause a problem here later on? So I think what I would say here is, I usually call this pattern crossing the streams, a bit like Ghostbusters. So if you start doing this, you're going to make life really difficult for your integration team. So I think if we can try to avoid that, it's a good thing. Or maybe have an ad hoc environment specifically for doing this kind of crossing the stream environment. And I would definitely say, when you're looking at UAT, one of the things we're testing for here is stability before you go to production. So try to avoid crossing the streams here. And, as much as you can, if you want to do it here, or you want to do other environments specifically for doing that, fair enough. But just as an anti-pattern, I would say this is going to create challenges for you. Okay, so patterns. So once we've got our environments, we need to think about the types of patterns that we're going to build in our integration platform. So do we want batches? Do we want messaging? Do we want events? Do we want APIs? Do we have ordered delivery? Do we need, I don't know, I think there's some others off the top of my head. Do we need convoys? And there's a whole bunch of other patterns that you might want to think about. So, if you go back to the Enterprise Integration Patterns book, there's all sorts of various ones there. So the ones that you're more likely to want to use, the chances are you'll probably use quite a lot of them, but there'll be certain patterns that will be required for certain applications. So, for example, a good convoy type pattern is we had an integration where we had this, we'll just call it System A, and we had 10 integrations here, and they all call System A, but there was a kind of a requirement that we had to do a convoy for any updates into System A. So we had to actually redesign how it was built because of an application requirement here. So we could almost have these separate integrations dump into a convoy processor here, and that could manage those going in. So those kind of patterns can help you decide which types of Azure resources out of the big diagram at the start you might want in your platform, but also which kind of patterns you might want to design building blocks for as well. So spend some time thinking about that. I think is a good thing. Next up, we're going to think about design choices. So this is really starting to get into the question about which things on the Azure Integration Services do I want. So you need to start thinking about what else does the organization have. So that's a good question. If we come in with a brand new greenfield, Azure Integration Services is completely at our disposal. But if we come into a company that already has an integration platform, they may have made some design choices. So a really common one would be, let's say, a company's already got an API management solution. So if you're coming in, you're going to build integrations, but you already have Apogee, or you have, I can't remember what the other vendors are now, one of the other vendors for APIM, then the question would be, do you want to introduce Azure APIM? Do you want to, some companies might say, well, actually APIM on Azure is a good strategic decision, so we might look to get rid of that and replace it with that. Or you might have another company that says, well, we've already got this big investment here. Can we just reuse that investment for all of our integration platform stuff? And we'll just leave APIM out on Azure and just not use that. So those are the kind of decisions where you need to think about this architecture. This is the relationship to the enterprise architect. What things have we already done? How do we work now? And how should we extend for what we're going to do? You would then sort of look at the Azure Integration Services offering. So you'd have some questions like, well, for hosting, is a great one to think about. So let's say we're going to use functions, logic apps, and a few other things, APIM and stuff. So you might have a company who prefers containers. So you might say, right, well, if we want to have containers, maybe we prefer that to app service type plans. So, maybe you'd say, if you're brand new to it, app service might do a lot of the work for you and you don't want to have to manage a container infrastructure. But if you've already got a container infrastructure, you might want to reuse that. So you might decide things like container apps or self-hosted gateways for APIM and AKS. Or you may have your own custom Kubernetes. So that might influence some of the design choices you make to favor those technologies. Whereas if you didn't have that already, you may favor app service. If you're going to have things like network integration, then you might say, well, okay, we might be better with an ASC. So I've done a video previously about that. If you're doing functions and logic apps and you want to connect to a network, you can simplify your networking by using an ASC. But then again, if you've got the container choice, so as of right now today, it's not necessarily for logic app standard, but you could definitely use it for functions. You've then got things like, well, what about things like the logic app standard versus consumption? So there's a whole video I did about comparing the two of them, and that would influence some of the decisions you'd make if you prefer, the kind of pay-per-click versus pay-per-hour type models. That would influence some of the choices around functions. Well, actually, functions APIM and logic apps could both be done both of those ways, depending on what you want to do. And then there's things like in your design choices, things like, well, if I had, let's say, I needed on-prem networking, which might point me down the logic app standard route, but I had API management with a VNet integration already, it might be that I can use logic app consumption and go through APIM to get on-prem. If it's all HTTP based, for example, so that might be a way where you think you need network capability, but you don't because you've already got it, and all the integrations you're going to build are going to use HTTP, so tick in the box. You might have to think about things like data. So if I'm going to have an integration platform and I'm going to be storing data, so if we think about a lot of the time in BizTalk world, we used to try and avoid having a custom database, but the reality is a lot of the time you would need it. So you might have choices like Cosmos, you might have SQL, you might choose to use storage. What else? If you've already invested in a data platform, you might choose a Synapse data warehouse. You've got a whole bunch of choices there to think about how you would store your custom data, and there's pros and cons of each. You might then have things like, well, we said previously about events and messaging and that kind of thing. Well, when would you use Service Bus? When would you use Event Grid? When would you use Event Hub? The chances are it's not uncommon that you might need all of them, but you might have a preference for certain types of integration. And then you would be thinking about, well, if I needed network capability on some of them, they affect the SKUs that I'm going to think about getting. So there's a whole bunch of design choices to think about here. So again, think about that diagram at the start, think about the environments, the requirements, and then start making some of these key design choices about what would your preferences be for things like host and things like service bus, things like login, APIs, and that kind of thing. I guess other ones would be like coding languages, I think, as well. So we had a really interesting one. So a lot of the times people who've come from a BizTalk background are going to be comfortable with C#. But I guess think about people. So it might be the case that your Azure integration team might be not just BizTalk people, but it might be no BizTalk people even, but it might be people who've come from a VB background. So there'd be a question of, do you want VB.net for custom functions? If you've had, we had some guys out of quite recently out of school. They were used to using Python because that's what they were learning at school. So their natural inclination was to start coding functions in Python. If you've got somebody coming from your data team, they're probably used to Python. So again, you might want to spend some time thinking about, do we want to let people just use what they want, or do we want to have a standardization? And pick a particular type of language for your functions would be a good one. So, for example, earlier in the slide deck, I was talking about how I think when it comes to people, I want to make my development team interchangeable so I can pull people off projects and they can be productive very quickly on another project. To do that, you need standardization, which is why I prefer that approach. And then you're not having to suddenly learn a new language just because somebody else did a function in a different way. If you can standardize your team's skill sets, that makes life easier. Okay, so logical structure on Azure. So this is going back a little bit to our previous diagram. And I think how I'd like to draw this is, let's start with a platform. So I'm going to have a bunch of assets that are going to be considered the platform level assets in my integration platform. These are going to be reusable items that I'll build in Azure that can then be be used across a number of integrations. So I'll probably use something like a service bus. So I'll create a service bus namespace. I'll probably create an event grid domain. I'll create an event hub namespace. I'll create an API management instance. I'll create, now I think, let's think about bigger customers first. The chances are I'll probably create an ASE, and that would allow me to do logic app standard and to do functions. So I'd have a plan. You know, if I get more complicated, I might end up putting more plans and stuff like that. But let's assume for now at the logical level, I'll create my ASE and I'll have these two types of resource on it. I'll then have things like storage. So my logic apps and my functions are all going to need storage accounts anyway. So I'm going to leave them off the diagram just for simplicity, but that's going to be an implied part of what we need. But what I'd probably do is I'd have what I usually call EAI storage. So this would be data for our integrations that we build if ever I need to store something and get it. So I'd often maybe use hierarchical namespace potentially if we needed to. And I might have an integration puts a message in the storage account, somebody else can get it later. It's a bit like a long-term message box in a way. The chances are you're probably going to need a SQL Azure database. Now you might need that for to save data that you need to query for different types of interface, probably. It's just not uncommon that you're going to need one, so you might as well think about it from day one. At least you know if that requirement came up, that would be what you would use. So at this point, I think that'll cover a lot of requirements, but I don't think it's unreasonable that somebody might need a Cosmos. Just delete that. So there's a couple of different flavors of Cosmos as well, but a DocDB type Cosmos is going to be useful. You could also, if you think about something like a Synapse, so you've got Synapse Link for Cosmos and SQL. So if you're building a data platform and you want to be able to query these sources, you can. Synapse can also point to your storage account if you wanted to build analytics on that. Now, I would say in a big platform, it's not unrealistic. You'll have different use cases where you'll need each of these, but bring them in as you need them. We're then going to have, what I'd also do is I'd create a system event grid topic. On top of that storage account, so if ever you build integrations that put data in here, you can do event-driven reactive solutions triggering off events from the storage account. It's quite a good idea, so that could potentially drive a logic app integration. You're probably going to want a key vault. In fact, you should want a key vault. And then you've got things like you might want app config. So key vault would be for secrets and certificates. App config would more be for config settings. Is there anything? I'm sure there's something else. Let me have a quick look back on my. What else we got here? Data factory. Oh, I'm logging. Yeah, those two. Right, so we'll put things like App Insights, and Azure Monitor here. And that would be your platform level asset. So as you build different integrations, they're going to reuse various solutions. Now, what's going to happen next is I think you'll want a layer of shared components, and I'm quite a big fan of this. So here what you're going to do is you're probably going to build APIs, logic apps and functions that do common things that would make your integrations easier. So an example might be, let's pretend we've got SAP over here and we integrate with SAP via web services. So I might build an API proxy which sits on top of SAP and makes it easy to integrate with it. So I might encapsulate my security, I might encapsulate some specific login or some, maybe I wrap, I think if I remember right, we had some SOAP calls so we could send an XML message to it. It would wrap it with the appropriate SOAP envelopes to keep our logic apps simpler. So the idea would be, if I build, so while that's a shared component, I'd build multiple integration solutions on top of my platform up here, and they would leverage components from the platform and from the shared components to build the solutions that we need. So let's imagine we've got, over here, we've got a logic apps solution, and that basically pulls in something very specific from an SFTP site. It might transform the data, and it might call out to this API, which then encapsulates the calls to SAP web services. And that would be quite a good way of leveraging these reusable services, because I might also have this one that leverages my API proxy for SAP. My API here would kind of live over on my API-M instance. It might be logging to my App Insights. It might get secrets from my key vault, and maybe there's 2 or 3 secrets that I don't want all these integrations to know about, all that complexity. I just want them to call a service that I manage, and maybe this is like a managed identity here. And so they can integrate managed identity, we encapsulate it, and that kind of works. I guess one of the things over here, you might also do things like user assigned identity, and some of these might have system assigned and various combinations of that. Now, when we think about these these integrations up here, they don't all have to be the same thing. So let's pretend I've got logic apps standard, but this might run once a day. Do I really want the complexity of the ASE? That could be a consumption logic app that runs there, reuse as part of my platform, and that works great. Now, I might also have another integration where it leverages the ASE for logic app standard. It might talk to CRM through a connector, and then it might again talk to SAP through my proxy API, would be another way. And then what we'll do is we'll end up building API proxies for all of our key systems. So we might have a bunch of them over here. We might then have inbound APIs. So let's say we've got an application up here. So this would be maybe a function. So let's actually draw it here. So we've got a function and an API and a function here. And we have 2 applications that call this API, goes through the functions, and it just drops stuff onto Service Bus. That might be another reusable component that we can leverage to drive new interfaces. And then once our message is on Service Bus, that could trigger another integration out here that leverages those messages on Service Bus. So again, extensibility points. We might also have, so like Data Factory is a bit more of an interesting one. So you could argue that we have a Data Factory namespace down here, and you might put all of your pipelines in it. But the other thing is they're quite simple, so it might be that you have multiple functional interfaces. That would be data factories. So you've got a couple of choices, and I don't think it's necessarily a difficult choice either way. I think it's just what's a good deployment unit for you. And I think so here, I guess one of the other things you might do is you might build a layer of helper functions. So you might have one or two function apps with things like date conversions, logins, lookup. I think Sandra and I did a good one, which was like looking up the run history to get errors. And these are designed to make your logic apps easier. So you might have multiple different integrations all call these, and just centralize some of that useful functionality. And I think again, building up the platform. So if you think about what layers we'd call these would be my common platform layer assets. These would tend to be some of the more expensive resources as well, things like your service buses and your APIMs. We then have, and these would, I guess, be general, common to most customers. Then your shared components. The patterns would be common, but the implementation would be specific to each customer. So you build proxy APIs, you build inbound APIs, you build helper functions, and you might have reusable helper logic apps as well. Might be another one, so you can maybe call them through APIM or directly. And there's a couple of ways you can do that. So they would be your shared components. I sometimes call these building blocks. And then up here, these are what I would describe as your functional integrations. So these are specifically solving a business requirement. These are helping you solve many building requirements, and this is the kind of platform it all runs on. Hopefully that gives you a bit of a logical structure of how we're going to build stuff. Then the physical structures. So we've got things like how are you going to structure it in terms of your Azure setup? So you've got things like subscriptions, resource group, I can't spell. You've got things like RBAC access. You've got different tenants. So some customers might have multiple tenants, and there's different nuances again how you're going to do that. So I've seen things where it ranges from a customer has one subscription, it has hundreds of resource groups, and then one of these resource groups is for the integration team. And then you might have different environments in there. You might have a scenario where you've got EAI dev, EAI UAT, a resource group per environment. Or you might have a customer who has a dedicated subscription just for integration. You might have a partner who has a subscription that you use, and there's all sorts of different flavors. I think just make sure you understand what works for your company and document it so it's really clear, because if you have people leave and new people come in, understanding your deployment layout, I think, is a really important thing. And not just for what you do now, but also how do you expect to do stuff in the future. Okay, so DevOps repos. So let's say we have our platform built. There's a couple, how are we going to manage the code for our platform? So whether you use GitHub or Azure DevOps, I don't think it really matters that much. The important thing is you use one of them. What we do is we've got a dedicated EAI project. We're using Azure DevOps, and then we use the monorepo pattern. Now I know different people are going to do different things. I'm sure there's plenty of pros and cons of each. I've tended to use this pattern for a while, so I'm going to tell people what we do, and then if other people do it a different way, I'd love to hear about it, because I'm always interested in learning how people do stuff and what works and what doesn't. So we use the monorepo pattern. well, I guess we use multiple mono repos, I think, in truth. So what we do is we have a repo for logic apps, consumption. We have one for logic apps standard. We have one for Azure infrastructure. We have one for APIM, one for service bus, and kind of that's pretty much it. We might have the odd other one I might forget about, but what we're trying to do is create a standard repo for each of the key component types that we build, or we have one for integrations accounts as well, if I remember. Now the idea is let's just take the logic app standard repo. So you have one folder for each solution. So if we've got 10 logic app consumption solutions, there'd be 10 folders. And the idea here is, so one of the things that we used to have previously that was a bit of a problem is we had project-based repos. So I don't like this. I'm not saying it's an anti-pattern, but I don't like it. So we'd have a project would come along and it would build, say, 2 service bus queues. It would build a logic app. It would build a function, and then that repo would have some builds associated with it. And then the problem with it is, you can deliver stuff certainly, but the problem is the project will end. All projects have a life cycle. The project will end. Another project will come along. They'll build their repo. And then project names may change, and then you'll have some new project wants to change something a previous project built. So what do you call the new project? What do you do with the code? And it just becomes a bit of a mess, I find. And the problem is that it's like, I've got this function in Azure, I need to change it. I can't find the code for it because I don't know where it is out of the 100 projects we've done over a couple of years. So that, to me, just doesn't really work from a sustainability and maintainability perspective. If I have a component-based repo model, I know if it's a logic app consumption, it's in this repo here. If it's APIM, it's in this repo here. So that's step one. I know where the code is, and then what I can do from there is we can standardize how we build stuff. So in this, let's stick with the top repo, we would have a template solution, and every time somebody needs to build new logic app consumptions, they create from the template, and that's how we start standardizing. And then all of our logic app consumptions are all built pretty much the same way, and then that happens across here. So how I like to describe this is we call it our like assembly line based approach. So if you think of a factory, we make cars. I've got an assembly line of how do I build a logic app. And then I've got another assembly line that does APIM. And what I do is when we create a new folder, so under here there'll be one folder per solution, and then that's the start of the assembly line. We can just create logic apps over and over again because they all just work the same because they follow the assembly line approach. So things like the repo, the build, the deployment, the testing, it's all standardized around that. That's how we get an assembly line approach. What we want to avoid is every logic app being built a different way, because then that you can't maintain that, because you need one developer per solution instead of one developer who can manage the whole platform. Okay, so hopefully that covers the repos. Then if we go on to pipelines, so the repos, actually I guess the one bit maybe I didn't touch on here is branching. So branching's really dependent on how your company's going to build projects. So we, using the monorepo pattern we've got, we might have a decent sized integration team, but we tend to build small integrations, and we have like fairly tightly managed change. So it becomes not that important to have a complicated branching strategy. So we can kind of do it fairly simply. But there's other times you might work in a company where there's multiple people changing the same integration at the same time for different projects on different timescales. Then it gets really complicated, and you need to one, design to support that, and two, you need a branching strategy to support that. So I think, again, thinking early on about how you're going to be working means that you can manage that complexity. So the more complicated your branching and deployment, the more likely you are to need a dedicated person who just manages the whole DevOps process. The more you can keep it simple, the more you can standardize your approach, which allows everybody to do the DevOps process and everybody to develop. And I think the more you can keep towards that second approach, the more scalable your team will be. And if you start having to have specialist skill sets, it just raises your cost of ownership. But also sometimes you need that because you're making it, your complexity drives it. So just factor that into the thinking. Okay, so DevOps pipelines then. So how you do repos and how you do branching is going to affect this. You've got a key question about YAML versus let's classic, we'll call it. So one of the things I tend to find as a bit of background on this, right? YAML's the cool kid way of doing DevOps pipelines. It's powerful, it's really cool, but it's a very very complex skill set for a team who aren't used to doing DevOps. So often I'll find that integration teams will have people who are really good at integrating technologies, but they tend not to have a massive amount of experience with DevOps. Certainly it's a lot better nowadays than it used to be, but again, it's a case of, do you want to have a complex skill set for your team to have to maintain on top of the other 20 complex skill sets they're going to have? So I would expect that it's most likely a lot of companies have probably been using Classic up till now. If you're coming in new, there's an argument to say maybe you should look at YAML because that's the way things have been going for a while, but I haven't seen anything particularly driving a deprecation of Classic. So I think what it really boils down to is, when it comes to DevOps, do you want a low code versus a code experience? What I would say on that though is, if you think about how I've talked about standardization to this point, if we're following a standardized approach, the assembly line type approach I've described, if we use YAML pipelines, it doesn't really matter that much because most of the time our pipelines are exactly the same. So every logic app component would have a pretty similar DevOps pipeline. So there it doesn't matter whether it's code or low code. But the more variances you have in there, the more you need to think about, can your team develop in YAML okay? I mean, I've seen some YAML pipelines just get crazy complicated, and I would dread to have to support them. So taking away some of that complexity with low code might be the right decision for your company. When it comes to the pipelines, so the chances are, let's imagine over here in Azure, you've got, you're going to deploy your function app. You then have this pipeline. Your pipeline might look up from Key Vault. You might look from app config. You might inject variables in, deploy your functions. You might have these, functions can look up stuff from here at runtime. So you've got this, you've got to think about your preferences for runtime versus deploy variables and secrets. So how do you want to do that? Do you want to, if it's at runtime, you've got the how often does the cache get refreshed? If it's deployment time, well, if it changes, you have to redeploy. And there's pros and cons of each, and you probably have a bit of both. You've then got things like your deployment units. So this pipeline, you could have it just deploying a function, but it's not unrealistic. You could have it deploy a service bus, and you could have it deploy a logic app all from the same pipeline. But that's going more towards a solution-based approach of what that solution needs versus a component-based approach, where you sort of have an assembly line that produces each type of component. Now, there's pros and cons of each again. You need to think about what you want. The reason I prefer the component-based approach again is for standardization. So if I have a solution approach, my pipelines are all going to look a bit different because they'll have different things that get deployed. If I do a component approach, then they'll be a bit more standard. But then we also you do have things like, well, okay, so I've got a solution or a project that needs 10 components. So you can either manage and deploy them manually by triggering each pipeline, or you can have some kind of release orchestration approach. So there you might build a pipeline that calls other pipelines, and there's marketplace widgets that let you do that. So you can actually have one pipeline to rule them all, where you can do, like we do this for our shared components. If we want to refresh them, we can just one click and it runs all of their pipelines together, and you can build models up around that. But that's some of the things to think around pipelines. Okay, so support and monitoring. So here you've got to think about how you're going to do it. So back to people, who's going to do it? So do you have a support team? Are your developers going to do it? Are you going to have a bit of both with an escalation path? Do you want business users to be able to see anything? So people in your support process will drive some of the technology choices you're going to make. You've then got the tooling, so you've got things like App Insights. You've got things like Azure Monitor. You've got Azure Metrics. So there's some of the things that will give you information about how your application's performing. And then you're going to then need to think about how these people are going to use these tools. So the big problem is there's nothing in this space in Azure right now. Devs will be okay using them. Things like App Insights doing distributed tracing across components is really powerful. The support team is going to be a bit of a gap. So again, do they have the skills to do this? Do they have the right access? Can they be given too much access and do activities that their skill sets would be a risk if you allowed them to do? So you've got to think about some of these things. I think the big challenge, like caveat, I've got a conflict of interest in the presentation here because me and Saravana talk a lot about serverless 360. I help drive a lot of the feature development in serverless 360 and do a lot of the advice on how customers can use it. So this is where I think if you've got your devs using these tools, they can do a lot of what they need. They'll have challenges around the holistic view of how your solutions work and managing the complexity. But you're going to need extra devs to be able to support the solution. The challenge is going to be these people here that we've mentioned don't participate. So with serverless 360, this is built from experience in the field, where we're kind of creating the tooling to allow your support team to manage your solution from a technical component perspective without needing to be an Azure expert. And it should tell them what the problems are and help them do that triage troubleshooting to reduce the load. So if I need extra developers just to do support, but it's actually low value tasks, I can have fewer developers by letting my support team do more. And then the business super user who can do self-service on their transactions, check where their orders are going. Again, that means that doesn't escalate to the support team, who then can't do anything, who have to escalate to a developer just to check that, yes, we did receive an order, which is really how it happens in the real world with the Azure portal, because of the gaps in that supportability of a solution. So that's where we're trying to fill the gaps with Serverless 360. And I think that gets you the full end-to-end kind of capability. So, just to call out, if people want to know more about that, feel free to get in touch and we can hook you up with a team to learn a bit more about that. But there are tools on Azure, so you're really looking in that space here. If you want a more mature experience, you combine these tools with Serverless 360. And thinking of the diagram before, so, you're maturing your platform, you're going to get kind of here. You want to get up here, which is where serverless comes in. But then business self-service is the bit that comes back to right at the start of the presentation, the PR, about telling your business users about the success of your product, that, your integration product, telling the users about what's going on and giving them visibility. That's how you get up here, and that's where business users come along and go, we want your integration team to build solutions because we get a good service, we get a reliable platform, and it works well. Okay, testing. So if we think about testing of your integration platform, so we've got unit testing, which hopefully in 2023 most people are doing now. If you're using the technologies I've described here, so you're going to be using things like Postman for APIs, you're going to use SpecFlow for BDD, you're going to be using things like NUnit, XUnit, MS Test, and one of the other frameworks. They'll be common for things like functions, logic apps, etc., etc. You're then going to think about, well, what about after unit testing? So we had all them other environments. We go past our dev environments. So your auto build is hopefully using all of these things on a build agent. So you have not just it runs on my machine, but it can be reliably tested. And then you're going to go to system test. So at this point, you've got the question of, right, what am I going to do? So the first thing most companies are going to be doing is manual testing. So this is where you're going to do something in CRM. It's going to trigger an integration, and that's going to do something in SAP. So please document these test cases. A lot of companies forget about that, or they'll document them as part of a project. The project ends, and 6 months later, when we need to change something, nobody can find the test cases. So some kind of centralized test case management will be a good idea. So you've got things in DevOps that'll help you do that. There's other tools. Even if it's just Word documents in a team site is enough, but please keep them as a test team site, not scattered all over SharePoint in various projects. If you can automate these tests end to end, that's a good thing. Now you can potentially do it with some of these tools like SpecFlow and stuff. You're going to write code to drive systems. You might even do things like say you do Power Automate RPA. You could maybe drive the UI on a system. You can do, I think it's Playwright. You've got, let's put SpecFlow here. There's many third-party things that you can do. So the question is, do you invest in those or not? So to me, manual's easy for exploratory, but if you've got repeatable tests, especially if you want them to be ones you can just deploy and repeat as a regression exercise. They're potentially good ones, but there is an investment in time to do this. So if you don't really have a test team, and your test team you do have doesn't have any coding skills, then you're going to find this a struggle. So again, that's going to push you back to the manual testing. But if you can do this, you invest the time in a long-term sort of life cycle of an integration, that might save you some money long term, because you can make lots of changes. So I would be targeting things that are high value, things that change a lot, like a lot of things changing around it, but you need stability and you need a lower risk, then that can help you. UAT testing. So this is where, again, it's, number one, it's like who's doing the UAT. So is it actual business users, or have you got a team of testers who work with business users? Again, I think it's pretty much the same manual and automated discussion here. It's just probably more likely you'll be manual unless you've got a really big test team. What was the other thing I was going to say? Performance testing. Actually, on UAT, I think one of the things, just to call it out, so from an integration perspective, when we have used Serverless 360 with customers, that's one of the areas where they see big value is UAT, because the business users can see the integration executed, they can see what happened, and they can even troubleshoot errors. That can lower your integration team costs by having your developers spending less time helping UAT, but it also increases the confidence of the business because they can see the integrations. Performance testing, so you've got a whole bunch of capabilities, whether it be Postman or the Azure load testing tools. They might be specific for different types of integration. So maybe if you wanted to load up an API, you could also do things like if you load a queue, you can track the metrics. So let's say I load a queue up and my logic app goes up here in my queue length, and then it comes back down. You can be watching for the time it takes to drain the queue. So there's lots of metrics in Azure that can really help you kind of do that, which will be good. And I'm sure I could do a whole other session on testing. That's a brain dump of the things you should be thinking about as you start your integration platform. Cost. Okay, so cost's really important. And I've left this as I think it's the last slide, if I remember right. Yeah, but actually this probably should be one of the first slides. And I think in hindsight, I often say to customers, don't leave this till the end. So I've made that mistake. What we need to think about is how are we going to pay for the platform, and how are we going to manage cost not getting out of control. So often what will happen is, let's say we've got our Azure here, we start doing some stuff, and then your bill shoots right up, and then everybody's like, oh, what happened? We've got this big bill. Where did this come from? Sometimes it's too late to make changes, because you obviously want to get this back down as quick as you can, but you might level it off. You might have to make a whole bunch of changes to be able to bring this back down. So so this is where, how do you identify these things ASAP? How do you get on top of cost from day one? So first off, who's responsible? Who's responsible for your integration team's cost? You need to identify that early on. So because it's probably an IT cost, it's probably going to be the IT director. So you need to know who that is so you can report to them. So that's who's responsible for it, but who's accountable. So there's going to be an EAI lead of some kind. That's the person who needs to look at the cost. And you need to manage a budget. So that's the person who needs to care about this. The question here is, do you actually look at Azure? Are you going to know how you've spent your money? Are you going to actively do that? How much time is it going to take you to do it? How often are you going to do it? How are you going to report your costs up? These are all things you need to think about. Now that we've talked about people, that touches on process, and then there becomes a bunch of technology questions after that. So if we know how much we're spending, right back at the start, we would have made some decisions that would have influenced what we're spending. So cost decisions. Cost impact on design's a big thing. So this is where a couple of times I've said, well, you might do logic app standard, you might do consumption, you've got options for functions and APIM the same. These are the decisions that you would make that might influence your costs. So maybe you say, we want our integration platform to be able to handle the load we have in this budget range. That would, so you might say, well, if we did this in Logic App Standard, it's going to cost a significant amount of money. If we did it in consumption, if we did it in standard, it might be a lot cheaper. That would be a design decision that you might refactor. Even if you often would use consumption by default, you might say, in this case, we use standard because it's going to be better value for money. The same applies for things like networking. So if I need to network things like private endpoints and VNet integration for things like API management, service bus, logic apps, functions, they're all things that start bumping the price up. So you need to think about, do we actually need these things, or are they just nice to haves, and could we save a lot of money? Can we actually decide to use certain components for some solutions and certain components for others? So some kind of although it touches outside of cost, but things like categorizing, security, confidentiality. You might say, if we've got a certain integration that has very low security requirements, there's no confidential data, it's low risk, you might decide that it's better value for money to not worry as much about some of the private network and things that might just massively increase the cost for limited value. So the trade-off between cost, value to the business, and security, that's really, I guess we'll do a little triangle for that. Security, that doesn't say security, but it's close enough. So really, where are you in this matrix? The more you want security, do you really care about really high security if the value's really low? Maybe you do, maybe you don't. Are you going to pay a lot of money for something that doesn't really provide any value to the business? And those are the kind of things you want to think about. So that was a brain dump of just off the top of my head, how do I answer some of the questions that I've had? I'm sure there's loads more come to mind the minute I stop recording the video. Hopefully this will drive some conversations, and maybe people might want to join me for a meeting sometime and we can just get the whiteboard open and bounce some ideas around and record it and share it with other people. That'd be quite cool as well if anyone fancies that. But thanks for listening. Take care, everybody. Have a great week. See you later.